Okay, we're looking mostly settled. So next up, we have Charles from LunarG, Charles Giessen, to talk about installation issues.
Okay. Hello. So I'm Charles Giessen. I'm from LunarG. I work on the Vulkan loader primarily. I maintain that. That means I'm knee deep in installation issues. And whenever someone has issues with Vulkan in that domain, I'm the person that they ask about it. So quick summary, what we're going to go over, what the loader is, because not everyone here will know what it is. Looking at the log the loader produces, we'll talk about finding the loader in the first place. We'll have some discussion of layer debugging when layers aren't present. And then we'll talk about implicit layers and when they are present. And then lastly, we'll have a little bit of debugging of driver issues. So big disclaimer, I work on the Vulkan loader, which I keep saying, but it's the desktop Vulkan loader. The Android loader is a separate code base. Android's a separate platform. I don't have almost any visibility into that, and I will not be saying anything really relative to that platform. So just so you know, if it's Linux, Windows, Mac OS, that's what I'll be discussing today. So dive in. What is a Vulkan loader? It's a library. It's a front end for all your drivers, and it does layer stuff too. It's the first thing all Vulkan applications use to talk to the Vulkan API. And because it's the first thing, if the loader isn't working, nobody's working. But as far as what the loader does physically is manage the VK instance object and setting up function pointer dispatching. So in previous APIs, you might have linked directly to a driver or linked to something like directly to the driver. Vulkan allows people to use multiple physical devices, multiple drivers at once. So it needs a thing to glue all of the disparate drivers together. And that's what the Vulkan loader is. And because we have this, we added a cool layer feature, and it's third-party plugin code. And it also, because it has to deal with multiple drivers and these layers, it manages all the function pointer dispatching. Whenever you load a function pointer or call a function, it will correctly send it off to the right place. So the API call chain, whenever you call VK destroy command buffer, whatever Vulkan function, it'll start with the application and then go down the chain in a specific order, which I have diagrammed in the pictures here. It's more of a stack than a chain because as it goes down, it will come back up in reverse order, just like a recursive function call. And the order, there's two pictures here. The top one is instance level and the bottom one is device level functions. So the instance level will have a loader trampoline. It'll go through all the layers that the function will go through, and it'll hit the terminator, which for instance functions dispatches to all of the drivers and will collate all the results. Like if you call enumerate instance extension properties, it will call that function on all the drivers, get that list, and put it in its own list, and then get the next driver's list and bring it all together and then return it to the application. Whereas with device functions, there's only one device, so there's no need for a terminator to dispatch to multiple things. It goes straight to the driver. And in this lower diagram, this is a linked function pointer, meaning it has to go through the trampoline. You can, in almost all cases, get rid of that loader trampoline dispatch by loading the function pointer directly using git procat or dlsim. So I just mentioned layers earlier. What is a layer? It's a plugin to the API, but rather than it being a side plugin that just offers additional functionality, it sits inside the call stack, allowing disparate tools to modify and intercept function calls as needed. The best example of a layer being the validation layer, and that allows you to debug your application of invalid Vulkan usage. And then during a release, you can take the layer out and now your application runs a ton faster. The layering ecosystem is awesome because it is a single interface for all these disparate third parties to work together. If we didn't have layers, every third-party plugin would have to try to intercept the application, would try to DLL injection, any sort of weird and wild way to make it work. But having a layer system means they don't have to do that. They just have to follow these rules. And now they have access to the Vulkan API. There are two types of layers, explicit and implicit, of which explicit layers are explicitly enabled and implicit layers are implicitly enabled. If that was the only distinctions, life would be a lot easier. What the distinction exists for is so that certain layer types that are meant to be turned on by application developers are in one bucket, the explicit layer bucket, and other plugins that should always be active, say game overlays, stream capture, post-processing, any physical device sorting, any of those things can just always be active for everyone. Implicit layers have some differences, but one that is a fun little tidbit is that they can filter instance extension lists, which is something explicit layers cannot do. And that sometimes causes issues, but it's mostly fine. I should say an example of that is RenderDoc, and that way RenderDoc can validate the extension list and remove anything that isn't supported when you're trying to do a capture. How does the loader find layers and drivers? Well, I'll get to that in a second, but once it finds them, it has found a manifest file. These are JSON files that contain information about what the layer or driver is, and the library it is, what the version is, its name, and other details that I don't need to get into. The primary value in the manifest file that the loader is concerned with is the library path. This is a path to a binary. Layers are plugins. Drivers are binaries. They're drivers, and they're binary code that has to be loaded, and the loader needs to know where that is. There's different ways for that path to be specified: absolute, relative, naked, as I call it, because there's not a great name for it. The naked being use the default dynamic linker search paths to find the library, say user bin or user lib. A little side note, layers have a name. The file name is not the name of the layer. It's the name field in the manifest file. That trips people up occasionally because you'll see, oh, layer name.json. No, that's not the name. That's just a file name. And it really doesn't matter what the file name is. Well, sometimes it does, but. So how does the loader find manifest files? It's platform specific. Who'd have thunk? On Windows, the loader uses the registry. These are the four main places that the registry that is looked in. You got the manifest type in angle brackets refers to implicit, explicit, or drivers. If you go into your own registry, you'll see the example at the bottom where you have a bunch of layers. They have names for the path, and there's a syswow64 for 32-bit, and then there's the local machine or current user for whether you're installing it globally for all users or just the current user. On Linux, there isn't a registry. There's just a file system. The loader doesn't know where to look in the file system. By default, it piggybacks off XDGs, environment variables, which contain lists of paths. These paths are then looked in by the loader for drivers and layers. I have a short example of some of the paths that would be searched. You know, home, etc, user, and then just some subfolder of it. And macOS, it follows a Linux-like pattern, but then is completely different in some ways. Because there's no XDG on macOS, we use fallback paths, like a /etc is a path that the loader almost always searches in because it's a fallback. And that's where if you installed, I think it's actually user local share on macOS if you installed it globally. But regardless, the primary way that you ship a driver or a layer in macOS world is inside the app bundle. That is something the loader knows about and will look in directly. And you have to use bundles if you are shipping on iOS, tvOS, because there is no system installed location. for layers and drivers. And the last place the loader will locate manifests through is environment variables. You have 4 primary ones: layer path, add layer path, driver files, add driver files. They will not be used if the application is running with elevated privileges. That's a security feature. Well, environment variables can be set by the user and could point to a user control path, which might have malicious code in it. So the loader just blankets, I will not search anything using environment variables if I'm running with elevated privileges, admin mode, what have you. The difference between layer path and add layer path is layer path redirects the explicit layer search paths, whereas add layer path adds to the default list of search paths. Same principle with driver files. It will set the path that drivers are searching, or it will add a new path to the default set of search paths. So let's now actually look at the loader log, the main debugging tool. Can I see a hand of how many people have actually looked at the loader log before? Fair number of people. A lot of LunarG people, which doesn't surprise me. Wonder why. It's the main tool for debugging installation stuff. By default, the log is written to std error, so it should always be there. And if you want to redirect that, know it's std error, not std out. The log contains lots of things of things you'd expect it to be in there, and some that you may not. Errors, warnings, info, where manifests are searched, what manifests are found, what things are loaded, what things failed to load, etc. So how do you enable the loader log? Well, with VK loader debug, that's an environment variable, and you set it equal to all. How exactly you set it equal to all depends on your terminal, your IDE, or whether you want to do it inside an application. So one nice thing about the loader log is that it prints to the debug utils callback as long as you provide a callback to the pnext chain of instance create info. That's a little bit of a fancy thing that not many people know about. They see, oh, I can create a debug utils messenger. It's like, well, if you want to get all the logs, you need to add one to the pnext chain of create instance and then create a debug utils messenger afterwards. If you're using an IDE, you'll set it however the IDE does it. There's many different IDEs with many different ways. So there's multiple levels of logging. You can control them through all your classic error, warn, info, debug. There's 2 special ones the loader has, which are layer and driver, and that will tell the log to print out every message related to layers or drivers. All is the one I suggest you use just because that way you don't miss any information, but maybe you just want warnings and errors. That's fine too. It's a comma delimited list, so error, comma, warn, that'd be how you do that. So let's look at the log and see what it contains. First, I should note that this is a compressed log where I took out intervening messages so that I can show you the breadth of what the log contains. So this is the loader on Windows looking for render doc. At the very top, we have looking in a registry. Say, hey, I'm looking for layers manifests. And the second line is, hey, I found a manifest. Oh, and this is the file. And it's from this registry. So we have program files, renderdoc.json. The third one is, oh, here's something interesting about the JSON manifest. And oftentimes deprecation notices are mostly for the layer developers. So if you're an application developer, you can mostly ignore it. It probably is fine. But moving on, then we have the, oh, okay, the loader is now loading the renderdoc.dll. This is the process that opening the binary. And lastly, we have it, okay, I'm inserting it into the instance. That is, I'm calling down the create instance chain and getting things set up for the application. So when I referenced the call chain picture at the beginning, that is a setup call chain. What is being described here is all the stuff happening inside VK create instance. And the loader is telling you what it's doing, where it's finding things, and what interesting tidbits there are about it. Once the loader has completed create instance, VK create instance, calling down the chain and back up, we've set up an instance, and the loader will helpfully print out a informational log. I guess that's the entire thing, but in this case, it's specifically which layers have been loaded and put into the call chain. So here I have OBS and the validation layer in that order. We start with the application, we hit the loader. So any function that goes down the call chain will first go through OBS and then through validation if those layers intercept that function. Then it hits the drivers and it will return back up the chain. It lists helpfully the name of it, the type of the layer, the library file it comes from, in case you need to debug further. Finally, during shutdown, we unload the libraries and the loader logs that as well, just showing you what it's doing. So I've talked about debugging the loader, but unfortunately you have to have a loader to debug. So sometimes you need to make sure that the loader is actually being loaded. That's a mouthful, isn't it? The loader on different operating systems has different names. You can see what they are here. And an application can either link or load the loader, linking referring to the dynamic linker opening the loader during the process startup, and loading the loader referring to the application calling load library or DL open or whatever platform specific system call you need to open the loader library. And that's the first step all applications do, whether application does it explicitly with loading or implicitly with linking. Well, why would the loader be gone? Why wouldn't it be on a system? Drivers are what provide the loader, especially on Windows. And if you don't have any Vulkan drivers installed, there's a fair chance you don't have a loader installed. On Linux, there's lots of packaging going on, and often the loader is in a package. So maybe you need to install a package to get the loader. On Windows, there is the Vulkan runtime installer that you can run manually to get it on there, but drivers call that during driver installation, so you don't have to do that yourself as long as you install a driver. Mac OS and iOS is the fun duck, odd duck out, because it's up to applications to provide the loader on the system because they're also providing the driver MoltenVK. So the application developer may want to put the loader inside their app bundle as well as the MoltenVK driver. Something that I really want to emphasize is that it's very unlikely that the hardware doesn't support Vulkan at all. If I was giving this talk in 2017, 2018, that would absolutely be true. But the last desktop hardware to not support Vulkan was 2014. It's 2024, so we've moved along quite a bit, and most hardware supports it, just needs a driver for it. Now, okay, the loader isn't on the system. What do you do? Could you install it yourself? Yes, I don't recommend it. Drivers do that for you. You could include the Vulkan 1.dll.so.dylib in your application. I also don't recommend that because it's going to be stale. Multiple times has the mechanism for finding drivers changed, leaving applications using an old loader unable to find the new drivers. So that is my recommendation, except if you're on Mac OS or iOS, like I said earlier, you need to ship a loader with yourself, just so you can even use layers and get the driver on your system. Additionally, I recommend loading the loader, not just for performance reasons, because the function pointers, you get one less indirection in your call chain, but also because when you do try to load the loader and it's not present, you can provide more information to the user than Windows can't start your process. Why can't you start my process? Because when you double click an application and nothing happens, that's all the output you get by default. If you're needing to load functions and load the loader, I recommend the Vulkan library for if you're using the C headers. If you're using the C++ headers, it's built into the headers, and you look at the documentation on how to use it. Okay, now we can talk about debugging layers. Specifically, layers not working. There are multiple ways to enable layers, and one of those ways will be used depending on context. Say you want to use an environment variable for locally just right here, right now in a terminal. Maybe you're using the Vulkan configurator and you want to set a profile or a configuration, or you're inside an application using the Vulkan API. I first want to ask you to make sure the name is spelled correctly. The environment variable, if you put a typo in validation and flip the letters, the loader doesn't know about that layer with the flipped levers. It only knows about the validation layer with that exact name. So make sure it's spelled correctly. But beyond that, there's many different reasons why a layer couldn't be loaded from it just not being, the manifest not being found, the binary not being loadable, or an error elsewhere. The negotiate loader layer interface function is something the loader calls on the layer to negotiate what version we should use. And typically, you shouldn't ever see that as an application developer, but if it goes wrong, it would appear in the log. So the first thing to check if your layer isn't loading is that the manifest couldn't be found. The JSON file is nowhere to be seen. Maybe you didn't set the path correctly. Maybe it's a / instead of a \, or you're one directory off in your .. // or the loader doesn't know to look in this place because you forgot to set the environment variables that will tell the loader to look in that place, say the VK layer path and VK add layer path. And if you are using those environment variables, make sure you're not running in elevated privileges. The loader log should tell you about that. Hey, I'm using elevated privileges. I'm not going to do anything with these environment variables. But sometimes it's easy to forget when that happens. On Windows, the registry, if you have a system installed layer, make sure it's in the registry. I'm going to go back and show you something there. The way the layers are in the registry is that the name is the path and the data needs to be 0 for the loader to load it. If you set it to a value of 1, the loader goes, oh, that's a disabled layer. I won't load that. So if the registry is correct, but the value is 1, then you need to change that. On Linux and macOS, make sure the layer is in the path searched, whether it's inside your app bundle for macOS or just in your home directory, user, whatever directory is being searched. Okay, now that we have the layer manifest found, what if the library isn't loading? It could happen for many reasons. The loader loads the library through the dynamic linker, DL open, and load library for Windows and Linux. And if it fails, the loader doesn't know anything about why it failed, except for what the dynamic linker is telling the loader, which is helpfully put into the log. So the quality of error messages is completely dependent on the system in question's ability to tell you what's wrong. If it just says error 126, that's not very helpful, but hey, if it's on Windows, maybe you can look up the error 126 in the Windows documentation. Loader doesn't know what's wrong oftentimes. It just tells you something's wrong, at least when loading libraries. Common issues that could cause this, maybe you're just missing the file, the binary file. The loader validates that the file exists by trying to load the file, because if it can't load the file, it doesn't exist. So on Linux, you may need to set the LD library path for a Vulkan layer that's from the SDK, because that's how they are found. On macOS, that's DYLD. Okay, library file is present, could be the wrong architecture. It's not too uncommon to accidentally compile your code with 32-bit or 64-bit and not remember that you're doing that, and then you're trying to use layers that are compiled for an opposite architecture of the one you're using. Oh, the layer might be loaded and it's missing a dependency, say on the standard library or pthread or something. I actually debugged the validation layers being unable to load because of a missing pthread dependency. It's very weird, but we've hopefully fixed it in the SDK, so no one else outside of LunarG should be dealing with that, hopefully. Lastly, code signing. Sometimes operating systems have very good measures to prevent malicious attackers from gaining process level execution rights by making sure you're not loading any untrusted code, which is why code signing can sometimes be a hindrance to loading these libraries, either because you built it locally or you didn't sign it, or a couple of other reasons. This is most prevalent on macOS because they have good code signing policies in place. couple of other odds and ends as to why layers couldn't load. Maybe you disabled the layer using an environment variable. VK loader layers disable can do that. And some other environment variables can too. Same with the Vulkan configurator, that can disable layers. Sometimes the layer is buggy, and whenever it's trying to create its instance, it just goes, oops, I can't load, and crashes the application, or just causes VK create instance to return an error rather than success. That's not something I can really help you with in a general sense, because that's going to be specific to the layers in question. Similar with RenderDoc and its instance extension requirements, it needs to have the right instance extensions or not have the wrong ones. And the layer may be going, I can't run, I'm going to shut down the process or shut down the instance so that it doesn't run invalid code. So implicit layers, we talked about how to load layers. Well, implicit layers are always loaded, and always enabled can be sometimes the wrong thing to do. I want to add a little detail that there are two types of implicit layers. There are always enabled implicit layers, and there are almost always enabled implicit layers. The almost always category being because these layers require a specific environment variable to be set and that's so that context-specific implicit layers can only run in the correct context. Best example being, again, RenderDoc or Nsight, where they only want to be running if the debugger or the profiler, whatever tool is coming from, is active. Still, they're implicit layers and are always being looked at and loaded by the, not loaded, but possibly loaded by the loader. I said earlier what the use cases for implicit layers are. I won't repeat that. So before we talk about how to disable implicit layers, I want to reiterate that they really do solve a real world problem that allows third parties to work together rather than against each other. That said, it's not a perfect world we live in. Vulkan is an open ecosystem. That means more or less any random application developer or tool developer can create a layer and install, and people will install it on their system. And if that layer doesn't work correctly or for other reasons, it can cause a lot of friction. So how do we disable an implicit layer? You set the layer disable environment variable. Every manifest for implicit layers has a disable environment key that specifies what environment variable needs to be set for that layer to not be loaded. This is a requirement of all implicit layers. If a layer doesn't have this disable environment, the layer is never loaded. It's invalid and will be rejected by the loader. This is the best way to disable badly behaving implicit layers. It's supported in all versions. It's specific to the layer. And if the layer developer fixes the issue and puts out a new version, they can change the environment disable so that the implicit layer will still run when it's the correct, good, not buggy one, and the one that is bad can be disabled only for that bad version. How do you find this disable environment? I mentioned that it's in the manifest, and well, the manifest is a file on the file system, so you'd have to look in the log to get the manifest path and then open it and then look through. That's a lot of work. We've made it so much simpler by just printing the disable environment variable in the log right there for you to grab if you need it. In the layer call stack or the VK instance creation call stack, it will print out the name of the layer, its type, and its disable environment variable if it's implicit. This makes it so much easier to find what it is because it's not always obvious what that name is without looking at the manifest. All you need to do is set it to a value that's a not empty string, 1, 0, anything, because the loader environment variables typically, if they are an empty quotes, that's unsetting the environment. So you need to set it to something for the environment for the loader to respond to the environment variable. There are always more than one way to do something in the loader, including disabling layers. I mentioned earlier the VK loader layers disable environment variable. That is a relatively recent addition in 1.3.234, so loader versions that and above. But this allows you to not just disable specific layers, but layers matching a specific name using wildcards, or using a special tilde all tilde, just disable all layers from being loaded ever. That's very useful for debugging, saying, hey, I'm seeing this weird issue. I don't know what's causing it. I'm just going to quickly disable layers and make sure there isn't anything funky going on. And if the bug goes away or the issue goes away, then it's probably a layer causing it. You can specify only explicit layers or only implicit layers in this disabling, and that's useful, but just disabling all is fine for debugging. Alternatively, you can use the Vulkan configurator. You can create a new configuration. You can select all the layers you want to disable. I have a couple of pictures showing that there, and it's the excluded/forced off option for each layer. And then just make sure that the configuration is active. Lastly, driver issues. It's mostly the same as layer loading. It's a library, there's a manifest, it has to load the library, it has to validate the thing works. It's most of the things I've talked about before with, making sure the path's correct, making sure it's the right architecture. That's all correct. If you're using environment variables to make a driver found, make sure you're not running with elevated privileges, again. But there's one big distinction. Well, drivers are required, layers are optional. If there are no drivers found on a system, you're not getting an instance. You're going to get VKAir incompatible driver. Sometimes that might be caused by the driver itself saying something weird, but 99% of the time, there are no drivers. Sorry, it's incompatible. I don't have anything for you, the loader says. This will often come from the drivers being improperly installed. Say you installed the NVIDIA driver on Linux, but the NVIDIA driver is incompatible with something. And so because there's only NVIDIA hardware, it can't load the driver when it tries to call create instance. And the NVIDIA driver says, no, I can't do this, and goes back up to the loader, and the loader goes, well, there's no drivers. Oh, well, sorry. Occasionally it's from implicit layers. Not always. It really does depend on which implicit layers. And unfortunately, if you're getting error incompatible driver, there's so many platforms with so many drivers, with so many combinations of possible global state, local state, and so many other things that I can't debug them all right here, right now. There's just too many possible cases to cover. But one that has come up relatively frequently is when a physical device reordering layer causes there to be no physical devices, or when the physical device isn't in the order you would expect or need them to be in. So there's 4 layers on here that I know of that do physical device reordering or sorting. There may be more. It's an open ecosystem. And which layers you have on the system may be causing different behavior based on what the properties of the system are, whether using Wayland or Xlib or other Linux or Windows capabilities that I don't even know of. And so if you're seeing issues with physical device reordering, it's just going to depend on which layer is causing the issues. Maybe there's 2 of them at the same time and they're fighting each other. Maybe you just need to disable all layers just to see if it fixes it. It's really too many to count. Well, lastly, I'd be remiss if I didn't mention that some issues are caused by the application. If you have invalid behavior, you're not going to have a good time. I've had some fun debugging sessions where it's like, it's crashing. Why is it crashing? Well, you're giving it a null pointer. I am? Yes. Oh, yeah, that would cause a crash. So extensions galore. Make sure you're enabling all the ones you're using. Features, same with the portability subset and portability enumeration are the key ones I'm thinking of right now. On Mac OS and iOS, you must enable portability enumeration when you're using the Vulkan loader for the loader to be able to give you Molten VK, if it can find it, of course. And I think that's everything I have. So I'm going to go through a quick recap of the big things to remember. use the log, has all the information you could want. Check your assumptions, like the name of the file, the name of the environment variable, that the path points correctly, that the path exists, that the file exists in the path. Lots of things like that. Disable implicit layers if you think something is amiss, like a validation error that is coming from someplace you're not really sure of. It might be the problem, might not be. And that the loader is complex, but I hopefully through this talk made it a little more approachable, and so you understand what it's doing, what its components are, and can hopefully debug issues that you have in the future. I didn't talk about everything I could have. If you have questions, we'll have Q&A just set now. But in the future, feel free to contact me, email charles@lunarg.com, and at Vulkan Discord, I'm active there, Charles G again. Hit me up, offline, online, anywhere. I really am happy to help with all your installation issues. I genuinely am. So again, we have a survey, take it. We have tumblers, take them. Thank you very much for listening. Question?
Yeah, you mentioned about the trampoline
Mhm.
right at the beginning there, and you said that some people elect to just bypass that and just, open the library, get the pointer. What would be the purpose of that? Why would you go to that extra effort for?
Because it's faster. It might not be super fast, but it's a little bit faster because if you link to the loader provides entry points that just call directly into the layer chain. And for device functions, that trampoline function doesn't do anything other than just call the first function. So you can bypass that by loading that function pointer manually or using a library to do it. And then every API call you make doesn't have to go through the loader at all. It can go directly to the first layer or even directly into the driver. And that's why it's a separate DLL.so. So when your compiler, it can't optimize out that function call. It's just extra indirection. And it might not be massive, but you're doing 10,000 draw calls a frame. 10,000 times of one extra function call could give you a little bit of performance.
So if you didn't have layers enabled, but you did just a regular link with the operating system to that library, you're still going through the trampoline. You wanted to avoid that, you could load it yourself and then grab that pointer.
Yes. One final thing, the documentation for the loader is in the GitHub, and it documents all this behavior and more. So if you want a more clear, more detailed explanation, look there.
Thank you.
Thank you.
Thank you. When you call or when you load the functions directly from the device, you have to provide a large list of all the function pointers that you want to get. Is there a place where I can get such a list and not provided by myself?
I'm not sure what you're referring to. Sorry.
So you have to load all the functions that you want. So you have to name all the functions that you want to have a pointer for.
So the source of truth is vk.xml in the Vulkan headers repo, but you don't have to do that yourself if you use a helper library like Vulk. They do the parsing and auto generation for you. If you're using the Vulkan headers, they also, the HPP Vulkan headers, they also do the same auto generation and do all the loading for you. So you don't have to do this manual work of VK get device proc add or get instance proc add.
Okay, thanks.